If you have not read the notes for this section, stop the video right here and read all of the vocabulary. You need to understand some terms about matrices. The elements in a matrix is each number, so this matrix has 12 elements. The rows run horizontally, so there are 3 rows. The columns run vertically, so there are 4 columns. If we were to name this matrix, we would name this matrix A, and it's got 3 rows and 4 columns. So the dimensions of matrix A are 3 by 4. Element 7 is in the second row, and it's in the third column. Here we're asked to write a zero matrix. A zero matrix is a matrix with only zeros in it. It is 3 by 1. That means it's got 3 rows and 1 column, and each element is 0. Here, what we're told is that these two matrices are equal to each other. That means that each element in one matrix is equal to that corresponding element in the other matrix. So W is equal to 3. Z is equal to 6, because these correspond. There's W in the same place as 3, Z is in the same place as 6. The next two elements are a little harder. We have x plus y equals 4, x minus y equals 5. So we could actually set this up like a system of equations. So we see that x is equal to 9 halves, y is equal to negative 1 half. And the last one, a and b are real numbers, and we're told x plus a equals 0, y minus b equals 1, and we need to find the values of x and y. This is actually a lot simpler than you think. So x plus a equals 0. Oops, not a. That means that x is equal to negative a. Y minus b equals 1, so y is equal to 1 plus b. Again, if you have not read the notes for section 16.2, stop the video and go back and read all of that vocabulary. Here we've got matrix A and matrix B. One thing that we should notice is that they are both 2 by 3 matrices. So we're asked, add them together. Well, an important thing about adding matrices is that you can only add, or for that matter, subtract, 2 matrices that are the same size. So what I've got and my resultant matrix will be the same dimensions as well. 1 plus 3 is 4. 3 plus 1 is 4. Negative 2 minus 5 is negative 7. 4 plus 0 is 4. 0 minus 7 is negative 7. Negative 5 plus 2 is negative 3. So this matrix is the sum of matrix A and matrix B. Next, we're asked to find the difference. One minus 3 is negative 2. 3 minus 1 is 2. Negative 2 minus negative 5, that's the same as plus a positive 5, is 3. 4 minus 0 is 4. 0 minus negative 7 is positive 7. Negative 5 minus 2 is negative 7. So pay attention to when I was subtracting a negative. Remember, minus a negative is the same as plus a positive, and you have to adjust. The last is what we call scalar multiplication. We're being asked to find negative 2 times matrix B. Our resultant matrix will again be the same size as B, and what we'll do is sort of like distributing. Negative 2 times 3 is negative 6. Negative 2 times 1 is negative 2. Negative 2 times negative 5 is positive 10. Negative 2 times 0 is 0. Negative 2 times negative 7 is 14. Negative 2 times 2 is negative 4. In this last problem, we're asked to solve for matrix X. So you'll actually approach this the same way that you would approach a regular equation. The first thing that I'm going to do is I'm going to simplify this right-hand sign, meaning I'm going to multiply this scalar 2 by each one of these terms. It's positive 2, not negative 2. Then what I'll do is I will subtract this whole matrix from both sides. So 2 minus negative 2, 4, negative 8 minus 1, negative 9, 0 minus 3, negative 3, 12 minus 0, 12. Now the last thing I do, most of us want to divide by 3, but what we're going to do instead is multiply by a third on both sides. This cancels and leaves me with matrix X. And then I multiply the scale of 1/3 to each one of these. and this is the value of matrix X.